Welcome back to the deep dive. Today, we're really getting into the weeds on unit testing. It's, a fundamental piece of building solid software. Our source for this is Chapter 12, the unit testing chapter, from Bhargav Bachina's big guide, Ultimate Full Stack Web Development with MEVN. Quite a title there. Anyway, our mission today is simple. Pull out the key stuff from that chapter, give you a shortcut to understanding why unit testing isn't just nice to have, it's pretty much essential for apps you want to actually rely on in production. We're talking building things right, from the ground up.
That's a great way to put it, because fundamentally unit testing is all about taking your code apart piece by piece and checking each little bit in isolation. It's definitely about finding bugs, yes, but maybe more importantly, it's about building confidence, knowing each individual component actually works the way you think it does, especially early on.
Okay, let's unpack that. Individual components.
Right.
What does that really mean day to day for a developer using, say, the MEVN stack? What is unit testing at that level?
Right. So for someone working with MongoDB, Express, Vue, Node, it means looking at each function, maybe each method within a class, or even a single Vue component, and testing it completely on its own. You're basically confirming, does this specific bit of code do exactly what I expect? You check its behavior against very specific predefined outcomes. It's like quality control, but super focused,
You said it's more than bug finding, but that's obviously huge. It feels like writing tests is more work up front, though. How does that actually save time or pain later? Convince me, convince the listener.
Oh, absolutely. It's a fair question. Think about it like this. Finding a tiny crack in a brick before it goes into the wall. Easy fix. Finding that same crack when it's part of a finished building, maybe causing leaks or structural issues, that's a nightmare, right? Way more expensive, way more complex.
Okay, yeah. Good analogy.
Unit tests are that early warning. They catch those small issues when they're cheap and easy to fix. But beyond bugs, they act as like living documentation. A good test shows exactly how a piece of code is supposed to be used and what it's supposed to do. That's invaluable when you or someone else comes back to it months later.
Ah, okay. Documentation that can't get out of date because it's tied to the code.
Exactly. And maybe the biggest win, refactoring and maintenance. If you have solid tests, you can change code, improve it, optimize it with confidence. Because if you accidentally break something, those tests will scream immediately. No more fear of touching old code.
That definitely shifts the perspective. It's an investment, not just overhead. So if it's that vital, are there golden rules, best practices to make sure the tests are actually good tests, not just there?
Yes, definitely. The book lays out some core principles. First up is test isolation. Super important. Each test should focus on only one thing, one unit. No dependencies on other tests or complex external states. Keeps things reliable.
Makes sense. One test, one job.
Precisely. Then there's test coverage. You hear about aiming for high percentages, but really, it's about quality over quantity. Focus on testing the critical paths, the tricky logic. Don't just chase a number.
Right. Sensible coverage, not just lines hit.
Then, test readability. Write tests that are easy to understand, use clear names, make the assertions obvious. A good test almost explains the code it's testing.
Like mini specs.
Kind of, yeah. And automation is key. Tests need to run automatically, usually in a CI/CD pipeline. Every time code changes, tests run, you get instant feedback.
Okay, automation is pretty standard now, thankfully.
And the last big one, which is really powerful, mocking and stubbing. This is where you replace real dependencies like a database or an external API with fake versions.
Fake versions.
Yeah, controlled fakes. You tell the mock exactly how to behave. When this function is called, return this specific data. It lets you test your unit in complete isolation without worrying about whether the actual database is up or the network is slow.
Ah, okay. So you're only testing your code's logic, not the whole world it connects to.
Exactly. That's the core idea of unit testing.
That's a really solid foundation. Let's switch gears a bit, though. Frontend Vue.js is obviously the V in MEVN. How do we tackle testing Vue components specifically? What tools does the book point to?
Right. For Vue, the go-to is Vue Test Utils. It's the official library specifically built for testing Vue components. Its whole purpose is to give you tools to mount your components in a test environment, interact with them like simulating clicks or typing, and then make assertions about their state or what they render. It works hand in hand with test runners like Jest.
So it lets you talk to the Vue component during a test.
Pretty much, yeah. That's good points. The API is pretty simple and intuitive once you get the hang of it. It allows for real isolation, testing components without needing the whole app context. It's flexible. You can test props, state, emitted events, the render DOM, pretty much anything. And it integrates well with tools like Jest or Mocha.
Any downsides?
Well, there's always a bit of a learning curve, especially if Vue itself or unit testing concepts are new to you, and the initial setup might feel a little more involved than just, writing a simple function test.
Okay, standard trade-offs. What about best practices when using it? Any specific tips?
Yeah, a few key ones. Always try to keep components independent in your tests. Focus on one at a time. Use shallow mounting when you can. This renders the component itself, but stubs out its children, which helps with isolation.
So you don't accidentally test child components too.
Exactly. And definitely mock dependencies. If your component calls an API, mock that call. Don't let your unit tests make real network requests. Also, keep things DRY. Don't repeat yourself. Use before each blocks for common setup code. And again, readability. Clear test descriptions save time later.
The book gives practical examples, right? What kind of things does it show Vue test utils being used for?
Yeah, the examples are good. The simplest is just mounting a component to make sure it doesn't crash on render. Basic smoke test. Then, accessing component data, like checking if a span contains the right text based on a prop or the component's internal data.
Okay, checking the output.
Right, and simulating user interaction. This is a big one. Clicking a button and checking if a counter goes up or if a method gets called.
Testing the dynamic bits.
Precisely. And also testing props and emits. Does the component react correctly to different props? When it performs an action, does it emit the right event with the right payload for its parent? Super important for component communication.
That covers a lot of typical Vue scenarios. Now, you mentioned Jest. The book brings it in too. If Vue test utils helps us interact with components, what does Jest actually do? How does it fit in?
Great question. Think of Jest as the conductor of the orchestra. Vue test utils gives you the specific instruments for playing with Vue components. Jest provides the entire stage, the sheet music, and tells everyone when to play. It's a full-featured JavaScript testing framework from Facebook. It actually runs the tests you write using Vue test utils or just plain JavaScript. It provides the assertion library, expect something not to be true, the mocking capabilities we talked about, and it generates those useful code coverage reports.
So Jest is the engine, Vue test utils is the specialized tool for Vue parts.
Exactly. Jest handles finding test files, running them, managing asynchronous operations, reporting results, the whole execution environment.
And what are the pros and cons of Jest itself?
Jest's big pros. Often easy setup, sometimes zero config needed. It's comprehensive runner, assertions, mocking, coverage, all built in. It's fast, partly because it can run tests in parallel. It integrates really well with, pretty much everything in the JavaScript world, including Vue and Node. And it has a huge community and great docs. Lots of help available.
Sounds pretty good. Any drawbacks?
There's still an initial learning curve to really leverage all its features, like advanced mocking. And while it uses JSDOM to simulate a browser, it's primarily node-based. So testing very specific, complex browser behaviors might sometimes require different tools, though it covers most common cases well.
Okay, so they work together. Vue test utils for the Vue specifics, just for the overall execution and features like coverage, watch mode.
You got it. Watch mode is great, by the way. Just watches your files and reruns tests automatically when you save changes. Super fast feedback loop while coding.
Nice. So for listeners wanting to set this up, maybe with TypeScript, which is common now, what are the key packages they need to install? The dependencies.
Right, setting up the front-end environment. For Vue 3 and TypeScript, you'll need a few things in your div dependencies. Obviously, a Vue test utils itself, then Jest as the core framework. Since you're using TypeScript, you need ts-jest, so Jest can understand your .ts files.
Okay, ts-jest. Makes sense.
You'll also need Jest environment JSDOM to provide that simulated browser environment for your components to run in. And often, a Babel preset env is needed to make sure modern JavaScript features are compiled correctly for the test environment.
Babel's still needed even with TypeScript.
Sometimes, yeah, depending on the exact setup and features you're using. And finally, at TypeSjust is super helpful for TypeScript integration, gives you type checking and auto-completion for Jest's API in your editor.
That's a good list. Vue utils, Jest, ts-jest, JSDOM, maybe Babel, and the types.
That covers the core setup for testing Vue components with Jest and TypeScript.
The book dives into specific component tests, like for create task, no tasks available, task stable. What are they checking in those examples, just briefly?
Sure. In createTask.spec.ts, it's checking things like, does the button text change based on a prop? And crucially, when you click the button, does it correctly emit a create task event? Testing inputs and outputs.
Standard component stuff.
Yeah. For no tasks available.spec.js, it's simpler. Just confirming it renders the specific no tasks available message when it's supposed to. A conditional rendering check.
Makes sense. And the table?
Tasks.spec.ts is more involved. It checks if the table renders the right number of rows based on the tasks passed in as props, and if the content in those rows is correct. And it heavily tests event emissions. Clicking edit on a row emits edit task. Clicking delete emits delete task. Clicking the row itself emits detail task. All with the correct task ID. It verifies the table interacts as expected.
Okay, so really testing the data display and the interaction points. Very practical.
Exactly. They show how to build confidence in those key UI interactions.
All right, we've covered the front end pretty well, but what about the back end? The Express and Node part of MEVN can just help us ensure our API logic is solid too?
Oh, absolutely. Just isn't just for the front end. It works great for testing Node.js backend code, including Express APIs. You just need a slightly different setup and maybe a couple of extra tools.
Different setup, how?
Well, your jest.config.js will specify testenvironment.node instead of JS-daemon. And you'll likely want libraries specifically for testing HTTP endpoints.
Like what?
The big one is supertest. It lets you make HTTP requests against your Express app directly in your tests without needing to actually start a server and listen on a port. It hooks into your app instance.
Ah, so it simulates the request.
Exactly. You'll need supertest and probably @type supertest if you're using TypeScript. Plus TS-jest, again for TypeScript support, and jest itself with @types-jest. Your tests would typically live in a tests folder in your backend source tree, and you might want to set a longer test timeout in jest.config.js if your tests involve, say, database interactions, which can sometimes take a bit longer than pure function calls.
Gotcha. The book gives a user service example for the backend, right? How does that work? How does it guarantee authentication logic is sound?
Yeah, the user service.test.ts example is a good illustration of backend unit testing. Its main goal is to check if the user service class handles sign-in and sign-up correctly. The key technique there is, again, mocking. It mocks all the services dependencies, the user repository, so it doesn't touch the real database, the logger service, even the user model. Everything external is faked.
So it's pure isolation again.
Pure isolation. This way, the test focuses only on the logic inside the user service itself. It uses the arrange, act, assert pattern, set up the mocks and input data, arrange, call the sign-in or sign-up method act, and check if the return value or any side effects are what's expected, assert. It also uses a before each hook to reset all the mocks before each test run, ensuring tests don't influence each other. It's all about verifying that specific class's logic in isolation.
Okay, testing the service logic. But what about testing the actual API endpoint that uses that service, like hitting tasks with a GET request?
All right, that's where supertest comes in, as shown in the test.ts example for the Todos endpoints. This is more like an integration test, but still automated with Jest. The setup might involve connecting to a test database using Mongoose before all, and disconnecting after all.
A dedicated test database, hopefully.
Oh, definitely. You don't want tests messing with real data. Then a test case uses supertest to send, say, a JT request to tasks. The assertions would check if the HTTP status code is 200 OK, and maybe if the response body has a specific structure, like containing a result array that isn't empty, confirming tasks were fetched.
So you're testing the whole request-response cycle through your Express app for that endpoint.
Exactly. It verifies the route, the controller, the service interaction, even if the service itself is mocked in deeper unit tests, and the final response format.
Okay, that makes sense. So we read all these tests, front-end, back-end, unit, maybe some integration-style ones. How do developers actually run them easily?
Yeah, the final piece is making it seamless. You just add a script to your package.json, usually something simple like test, jest in the script section.
And then just run npm test or yarn test.
Precisely. That command kicks off jest. It finds all your test files, usually anything ending in .test.ts or .spec.js or similar, runs them all, and gives you a nice summary report, passes, failures, coverage, instant feedback.
Cool. So Jest seems like a really powerful, almost all-in-one solution for MEVN stack testing. But the source mentions other libraries too. Is Jest the only game in town, or are there other options listeners should know about?
Jest is definitely hugely popular and capable, but no, it's not the only option. The JavaScript testing ecosystem is pretty rich. The book specifically calls out Mocha and Chai, and also the TAP library.
Mocha and Chai. I've heard those names a lot. How do they compare?
They're often used together. Mocha is the test framework. It provides the structure. It blocks, handles running tests, deals with async operations, reporters, that kind of thing. It's very flexible. Chai is purely an assertion library. It gives you different ways to write your checks, like the expect style, similar to Jest, a should style, and an assert style. People
Fun.
like having that choice.
So Mocha runs the tests, Chai checks the results.
Pretty much. The pros are that combination is highly flexible and customizable. Chai's assertions are very expressive, and they integrate well with other tools, especially sign-on.js for mocking, which is very powerful.
And the cons.
The flexibility can mean a steeper learning curve for advanced setups. Because they're separate tools, you might end up with a bit more boilerplate or configuration compared to Jest's all-in-one approach, especially for things like mocking or coverage, which need extra libraries.
So more setup maybe, but potentially more control.
Kind of, yeah. For best practices of Mocha Chai, you'd still focus on logical organization, descriptive names, using setup teardown hooks before each, after each, separating test types, and really leveraging Chai's readable assertions, and probably using sign-on for mocking.
Okay, and what about TAP? That sounds less familiar.
Yeah, TAP, or the test, anything protocol, is different. It's actually a simple, text-based protocol for test results. The TAP library is the Node.js implementation. Its big pro is simplicity. The output is very minimal and human-readable. It has built-in support for async tests and often includes coverage reporting out of the box. It also handles subtests nicely for organization, and it's very framework agnostic.
Simple output sounds potentially nice, but maybe limiting.
That can be the trade-off. It's less popular than Jest or Mocha, so fewer online resources, Stack Overflow answers, etc. The very simple output might make debugging complex failures a bit trickier sometimes compared to the rich diffs you get from Jest or Chai. There might be a learning curve if you're used to the BDD style, describe it, of Jest Mocha.
So TAP is more minimalist, focused on the protocol.
It's exactly. Best practices there involve using subtests well, leveraging the async support, keeping tests independent, and embracing the simple syntax. It's a different philosophy.
Wow, okay, so Jest is a strong contender, especially for MEVN, but Mocha Chai offer flexibility, and TAP offers simplicity. Good to know the landscape. This has been incredibly insightful. We've really dug into why unit testing matters, how tools like Vue test utils in Jest make it practical for both front-end Vue components and back-end Node Express APIs, and even explored alternatives like Mocha, Chai, and TAP. So wrapping this up, what's the big takeaway for you, the developer, listening right now? What does mastering this mean for the apps you build?
I think the core message is unit testing isn't just about squashing bugs reactively. It's about proactively building confidence into every single part of your application. When you take the time to isolate and verify each function, each module, each component, you're creating this solid foundation. That meticulous focus on the small parts is what enables you to build complex, stable, maintainable systems that actually work reliably in production. It lets you code faster in the long run because you trust the pieces you're building upon.
Confidence through verified components. I like that.
Yeah, and it leaves you with a thought, maybe. How does that rigorous discipline, ensuring even the tiniest gear in the machine is perfect, ultimately translate into the smooth, predictable running of the entire complex engine? It's that connection between micro-level quality and macro-level stability that's really powerful.